second example about relative density. A piece of copper metal of a volume 5.1 centimeter cubic has a mass of 41.6 gram. Calculate the relative density of copper. When you look at this question, definitely what you've been given from the question, we are having volume. That is V, which is equal now to 5.1 centimeter cubic. And then we are having mass. That is M, which now is equal now to 41.6 gram. But the question is to determine relative density of the substance. But remember, relative density of the substance is equal now to density of substance over density of water. But density of water is definitely constant. It is 1 gram per centimeter cubic. This is the density of water. But density of substance is the one that is missing. But definitely we calculate the density of the substance by taking mass of an object over volume. Kwa hiyo ukiangalia kwenye hili swali, we have mass of the substance and you have volume, but we don't have density of the substance. So by using this mass of the substance and it is volume, it is where now we can determine the density of the substance. Kwa kwanza tumeambiwa relative density. Kwa density of water tunayo ni constant, lakini density of substance hatuna. Kwa tunatumia masi tuliopewa na volume tuliopewa kutafuta sasa density ambayo ni mass over volume, and it therefore our mass now is equal now to 41.6 gram over, now it is density 5.1 centimeter cubic. This is what I have. From then here, once you take this one divided by this one, you get it is 8.16 gram per centimeter cubic. Therefore, this is what we call it density of the substance. Will be equal now to 8.16 gram per centimeter cubic. Then I have got the density of the substance. Then I have to come back from here. From relative density, density of the substance is 8.16 gram per centimeter cubic. But density of water is 1 gram per centimeter cubic. Mathematically, this cancels out with this one. It is where now you have 8.16 over 1, which now is equal to 8.16. This is the relative density. Therefore, we come to conclude relative density of the substance will be equal to 8.16. So this is the relative density of the substance. Therefore, the relative density of the substance is written in such a way that you have the density of the substance and you have the density of water. But in case you are having no density of the substance, you just use this formula to determine it is what we call it density of the substance. And it is a normal way of calculating the density of the substance. It is where now you end up getting this one. Once you have got this one, it is definitely you apply it in this formula so as you may find out what is missing. Kwa hiyo swali kama hili hapa, umepewa masi, umepewa volume, haujapewa density of the substance. Kwa hiyo unatumia kanuni ya kawaida ambayo ni density of substance sawa sawa na mass over volume, ambapo utapata density of the substance. Lakini kumbuka density of water ni constant ambayo ni 1 gram per centimeter cubic, ambayo sasa baada ya kumepata density of the substance unakuja sasa unaiapply ili uweze kupata kila ambacho sasa kinaitwa relative density. Kwa hiyo ni muhimu kuelewa swali ni kwamba umeulizwa relative density. Relative density kanuni yake ni hii hapa. Je, mahitaji ya kanuni yapo? Kama mahitaji ya kanuni hayapo, nini unakifanya sasa ili upate density of substance na density of water? So that is all about relative density. So calculating relative density of the substance is definitely so important to understand that it is all about density of substance over density of water. But density of water is definitely 1 gram per centimeter cubic or 1000 kg per meter cubic. Depends to what kind of the question are you talking about. If now it is given in terms of kilogram and meter cubic, you use that 1000 kilogram per meter cubic. But if it is given in terms of gram and centimeter cubic, you use that 1 gram per centimeter cubic. So that is all about calculating relative density.